2, 1. So where does the formula for combinations come from? When you start doing typically organized counting, you will then afterwards move into combinations where the order is actually irrelevant when you start counting. So these combinations come into play. The formula I state right here. Now this is under the assumption that you have studied n factorial and you also understand ordered organized counting, so that's permutations. Now if you missed the permutation side, I'll put up a link up above there. You can watch it, or you can go to my playlist on grade 12 data management and probability to get yourself set up. So now this formula is actually not very difficult to try to derive once you do understand permutations. So I'm going to do it through an example just to show you how when you remove order, you are actually kind of multiply counting the number of permutations that you have. Okay, so I'm going to come back to this formula and then show you how it comes into play. All right, but first let's take a look at an example in terms of combinations. So let's imagine that we have kind of 4 maybe teammates or individuals who are going to be playing, say, doubles in terms of tennis, right? Doesn't matter what their names are. So let's imagine that, you know, we have player A, player B, player C, and player D, all right? Now, to get doubles, so what we really want is we want to figure out kind of just 2 players out of the 4. And now what if the question was, you know, how many different teams can you make, right, that could play doubles? And, you know, typically when there's not a lot, so in this case A, B, C, D, we only really have 4 people, we can actually kind of just write it down. So what we're doing is we're trying to find out, okay, so how many teams of 2s do we have? And now if we were doing permutations, so if ordered matter, then that would have been set up a little bit differently, right? So now these 2 teams, what we can do is, you know, you can create a team of player A and player B, right? Now, it doesn't actually matter, right, if you selected first player B and then player A. So here, this would have been the permutation. We would have said, well, there's really 2 orders here, right? A, B, or B, A. But in terms of creating a team, it doesn't matter how you choose them. You know, it's still only the same 2 players. Now, you can continue this and you can say, all right, well, what else do we have? You can have A and C. And of course, you know, you can swap these, which would have been C and A, if the ordered matter, okay? But again, for choosing a team, it wouldn't. And you can now continue with this pattern, so A and D, and if ordered matter, it would have been D and A. And I'll tell you why, you know, I'm writing the order, okay, in general. Okay, so then, you know, I'll kind of run out with the letter A in here, so then it would have been, you know, B and C, and that could have been C and B. It could have been B and D, which could have been D and B. And then finally could have been C and D, or just D and C. So if you take a look at this, so how many teams did we have? Well, really we had just 1, 2, 3, 4, 5, 6. We had 6 teams. Now, in total, we had, so N, which was the total number of choices that we would have, or selections, or items to be selected. So there was 4, A, B, C, and D. And now, how many were we actually choosing, okay, or reserving? It would have been 2. And now, you remember, okay, if you were studying permutations, then the way to actually find out the total number of permutations, you would have just simply said, well, this is simply 4. Right? P2, and that is nothing else but simply 4 factorial divided by, you know, 4 minus 2, which would have been 2 factorial right there, and that indeed would have given us 12 because we would have been counting these as well, right? Because ordered matter. Now, because order doesn't matter, then we can't double count them because it's still the same team, right? So AB and BA are the same, AC and CA are the same, and AD and DA are the same, and so on with all the other ones. So really we just had 6 teams. So we clearly can't use this in terms of permutations, but we knew that because we know that order is irrelevant and for just choosing a team of players. So therefore, how would we get that 6? Sure, I can list them and then I can see, but you should notice a pattern here that once you select, so in this case, once we selected our first A and B, all right, in this way, we could, do every permutation of that A and B. Now, because we only have 2, then this would have been just simply 2 factorial, right? So how many different ways can we order A and B in? 2 times, which is just 2 factorial. And we're doing that for every single selection. So A and C, again, is 2 factorial, and so on all the way down. So you might kind of think that, oh, okay, well, if I wanted to now find out combinations instead of permutations, where order is irrelevant, then I can take this, which gives me all the permutations, but then each selection, right, has, the R number, so in this case 2, because we were choosing 2, R number of permutations. So I can take this entire thing, and to find for choose 2, you can actually say that this is for permutation 2 divided by, okay, the number of selections that you took, factorial, as you can see in all of these, right? So how many permutations were there for each? And this actually does tie into where your formula for combinations comes from. It is simply taking the total number of permutations, so Rn, choose R is equal to n permutation, okay, this would have been R, divided by simply R factorial, because we want to remove all the same ordered pairs that we would have, which would create, in this case, our team. And this, well, n PR is just simply n factorial divided by n minus R factorial, and this is divided by R factorial, which, as you know, if you know your fractions, then this, just simply rewritten, would have been n factorial divided by n minus R factorial and R factorial. And that is exactly where that formula comes from. And you can write it in different ways. So we can write it in this way, you can write it in this way. So it depends which textbook you pick up. I have, in the past, actually been kind of writing it like this when I used to study this topic. Okay, now, so if that made sense to you, great. Now I'm going to do one more, just so that you can see this again in action. Okay. And instead, what we would say, let's still imagine that we have our 4 players, but instead of doing doubles, maybe we're now doing, I don't know, 3-on-3 pickup basketball or something like that. So we're going to be choosing teams of 3, okay, from these. And I want to show you, again, how the process for this works. So if we have A, B, C, and D, and now we're going to be choosing teams of 3, so how could we do this? Well, you can first pick, so A, player B, and player C. And out of these players, so A, B, and C, okay, this would have been just one team. Now, if you're thinking about, okay, in how many different ways could you have ordered A, B, and C, right? Well, that's 3 factorial, right? There's actually 6 different ways that you can order A, B, and C. So you could have ordered it, A, and it could have been C, B. So that's another way. You could have ordered this B, A, C, or B, C, A, right? Or you could have put C first, so C, A, B, or C, B, A. Notice 6 different ways, which makes sense. It's 3 factorial, right? But all of these are exactly the same team of player A, B, and C. So if we wanted to know, so out of 4, so 4 players, and we were choosing 3, right? This would have just counted as 1 team. And now you can do the same thing. So I've chosen A, B, C. I could have done the same thing with A, right? B and D. And I would have done the same amount in terms of the permutation. So again, it would have been 3 factorial. This could have been A, D, B, right? So that's another one. Then it could have been B, A, D, or B, D, A, or D, A, B, or D, B, A. Okay? But this again is just 1 team. And I think you're slowly trying to see the gist here. So indeed, what this would be is, right, if I'm listing the entire thing out, then really what I'm doing, right, so if I would continue this, then what I would have been doing is I would have been taking 4 and then doing permutations by selecting 3. So 4p3, right? So 4p3. And now I have to remove, okay, so I would be dividing by my r, which is 3 factorial, to find out my total, right? Which again would bring me back to this formula that you would see. And you can now do this just in general. So this extra little r that we see, this r factorial, when we're doing combinations, comes from the fact that order doesn't matter once you make your selection. But in permutations, order did matter, so we had to actually do all of those different orders, right? So, you can do this and, you can create another team. So we went ABC, we went ABD. Okay, now you can certainly create maybe B, CD. So that's another one that we could have done. Okay, and you could have continued this throughout. So what else could there be? So we had ABC, right? ABD. I guess I missed one in here. So it would have been ACD. I guess we could have done that one. Okay, and all of these you could have had in 6 different ways, right? So in total, as you can see, if we were doing 4p3, that's actually equal to 24, right? So that's what that would have been, which is just 4 factorial divided by 4 minus 3, which is 1 factorial, so that's 24. And then this would have been divided by 3 factorial, which is really just 6, and that would have given us 4. And indeed, that's what it is. We would have had 4 different separate teams if we were trying to pick 3 players for each team. So I hope this gives you a gist of actually where that formula comes from. And that way you can kind of remember, all right, if you know permutations and you're familiar with it, which is typically the first initial thing that you start with organized counting, which is n factorial divided by n minus r factorial. And then just don't forget to divide by r factorial, right? That's it, because you want to remove the repetition of those ordered pairs, which still give you the exact same players or items, whatever it is that you're selecting. All right, so I hope that you found this useful. I will do a few other videos with applications of this, and eventually I hope to do actually the entire poker kind of probabilities at some point, and that uses these combinations quite a lot. So anyways, thanks for watching. We'll see you in a future video. Bye, everybody.